This is usually done for a product if the integrand is a product of two functions. So if u and v are two functions of x, then integral of u v dx is u integral of v dx minus integral of the derivative of u multiplied by the integral of v dx, whole integral. So how do we remember this? U is called as the first function, v is the second function. So the integral is remembered like this: first function into integral of the second minus minus the whole integral of the derivative of the first times integral of the second. So this is how we remember this integration by parts. Of course, this can be proved, and in preliminary texts on calculus, integral calculus, this proof is very readily available. But for us, we just go by this formula: first function into integral of the second minus derivative of the first into the integral of the second. Now, how do we now, if there is a product, how do we identify first and second functions? How do we identify first and second functions? First function is u, second function is v. Which in the product, which should be u, which should be v? So consider the acronym. It's ILATE. Okay. I stands for inverse trigonometric functions. L stands for logarithmic functions. A stands for algebraic functions. T stands for trigonometric functions. And E stands for exponential. Do you remember now? Okay.
Yes, sir.
Now, of the two, okay, of the two functions, whichever comes first in the sequence isolate shall be considered as the first function. And the other one will be considered as second. Okay. Now, that is one. This is one rule. Now, second is, if both are algebraic, choose first function as that whose derivative is simpler. Okay. And if it is trigonometric, generally this kind of case we don't usually get, but there's a rule we should know. If both are trigonometric, choose second function as that whose integral is simpler. Okay. Suppose there is secant x and cosecant square x. Integral of cosecant square x is cot x, but integral of secant x is log mod secant x plus tan x. So choose cosecant square x as the second function. That will make integral easy. This is by practice you get. If there is only one function, whose integrand, whose integral is unknown, choose that as the first and one unity as the second. So let's apply this to some problems and see. So okay. So examples we'll take for practice and then we'll move forward. First one, integral of x times log x dx. We need to evaluate this integral. How do we do that? Now there is x, this is log x. Now we go by isolate. Here we have a purely algebraic and here we have a logarithmic. Okay. So we have logarithmic and algebraic. So logarithmic should be taken as the first function. So we choose this as the first function, u, and this as the second function. Okay. So now integrating by parts. So integrating by parts, the integral I will be first function log x into integral of the second minus integral of the derivative of the first into the integral of the second. So we get log x into x square upon 2 minus integral of derivative of log x is 1 upon x and integral of x is x square upon 2. So this makes it easy. So I is half x square log x minus half integral x dx. So this is half x square log x minus half x square upon 2. And finally add plus c. So if we take this x square upon 4 common, we get 2 log x minus 1 plus c. Okay. So this is integration by parts. Once you identify first function, it is first function into integral of the second minus integral of the derivative of the first into the integral of the second, the whole integral. Okay. So this is standard one. Sometimes we may have to do it twice. Let's do this. Integral x square times cos 2x. Now please tell me which one will be the first function and which one will be the second function.
So x square will be the first one.
Very good. Because we have algebraic and trigonometric. So the algebraic has to be the first function. And this is trigonometric. So this is the second function. So now integrating by parts. So I'll not write all these steps again. So first function into integral of the second minus integral of the derivative of the first. One more time. I'm just writing for the second problem. From next problem onwards, I'll directly write the integral. Derivative of the first multiplied by the integral of the second. So we have x square. Integral of cos 2x is sine 2x upon 2 minus integral of 2x times integral of sine 2x upon 2. So 2 and 2 cancels. Half x square sine 2x minus. Now again, you get x and sine 2x. Again, we have to do integration by parts. Again, integrating by parts. Half x square sine 2x minus full brackets, a big bracket, first function into integral of the second. Integral of sine 2x is minus cos 2x upon 2. Okay, this is the integral of the second function minus integral of derivative of the first function. Derivative of x is 1 and integral of the second is minus cos 2x upon 2, all brackets. So we have half x square sine 2x minus times minus is plus x upon 2 times cos 2x minus into minus plus times minus is minus. We get half into integral of cos 2x is sine 2x upon 2. So in effect, we get this as 1 upon 4. So 1 upon 4 times sine 2x plus c. So this is integration by parts. So of course you can collect the sine 2x terms and cos 2x terms separately and simplify further. But this is the case where there is integration by parts used twice. All right, next we have some standard results. Okay, one more we will do, one more. And then 2 on integrate x times tan inverse x dx. So which is the first function and which is the second?
So tan inverse is the first function.
Very good. So there are two functions. X is algebraic. So we have inverse trigonometric and algebraic function. So x will be the second function and tan inverse x will be the first function. So integrating by parts. First function, what will it be? X. No, sorry. First function is tan inverse x times the second function integral dx minus integral of the derivative of tan inverse x into integral of x dx. So this is tan inverse x times x square upon 2 minus integral of derivative of tan inverse x is 1 upon 1 plus x square times integral of x is x square upon 2 dx. So we have half x square tan inverse x minus half integral. Now we have this x square upon 1 plus x square. How to solve this one? To solve this, we add 1 and subtract 1. When we do that, we can split this as half times integral of 1 minus 1 upon 1 plus x square dx. This is now in standard forms. We have standard results for that. Integral of 1 is x, and integral of 1 by 1 plus x square is tan inverse x. Plus c. So we can simplify half times x square plus 1 tan inverse x. I am adding the tan inverse x terms minus half x plus c. So this is integration by parts with an inverse trigonometric function and an algebraic function.